Welcome class 12th. In today's lecture we are going to discuss power in RLC circuit. That is, how much power is delivered in RLC circuit if current is I0 sin omega t and voltage is V0 sin omega t plus phi. Here we are leading voltage with an angle phi and assuming that circuit is inductive. So if the circuit is inductive, then voltage must lead by current by an angle phi in RLC circuit, as we have seen in the phasor diagram. So power in RLC circuit will be P is equal to V into I, and we have taken the equation of V as V0 sin omega t plus phi and I as I0 sin omega t. So we can write it as V0 I0 sin omega t, and we are going to expand sin omega t plus phi as sin A cos B plus cos A sin B. The expansion of sin A plus B we are going to use, that is sin A cos B plus cos A sin B. So it will become sin omega t cos phi plus sin phi cos omega t. V0 I0 sin omega t into sin omega t cos phi plus sin phi omega t. Now we have to multiply this term to both. So it becomes V0 I0 sin square omega t cos phi plus V0 I0 sin omega t into sin phi, and it becomes cos omega t. So V0 I0 cos phi, since phi is constant because it is phase difference, so we can arrange the equation by taking the constant terms at one side plus V0 I0, and here also sin phi is constant, and the equation becomes sin omega t cos omega t. We can write it by multiplying and dividing by 2, that is 2 sin omega t cos omega t. So the equation becomes V0 I0 cos phi sin square omega t plus V0 I0 upon 2 sin phi, and this is 2 sin A cos B, that is sin 2 theta sin 2 omega t. In this we are using the formula 2 sin A cos A is equal to sin 2A. So these two trigonometric relation we have used here. So after using this relation, what we can get? Power is equal to V0 I0 cos phi sin square omega t and V0 I0 upon 2 sin phi sin 2 omega t. This power is known as instantaneous power. Now we are going to calculate average power. So to calculate the average power, what we have to do? If you want to note it down, you can pause the screen and note it. Now in order to derive average power, so average power is equal to integral pt dt upon integral dt from 0 to t. That is the equation of instantaneous power. We are integrating with time and upon total time. So it will become 1 upon t, because this integration is actually t. Integral this whole equation of instantaneous power. So it is V0 I0 cos phi sin square omega t plus V0 I0 upon 2 sin phi sin 2 omega t. And dt. So just separate out the two integrants. 1 upon t integral V0 I0 cos phi sine square omega t plus integral v naught I naught upon 2 sine phi sine 2 omega t dt. Now if you see carefully this equation, v naught I naught cos phi is a constant term, so we have to integrate sine square omega t, and in this equation v naught I naught upon 2 into sine phi is constant, and we have to integrate sine 2 omega t dt. So the equation becomes 1 upon t v naught I naught cos phi integral sine square omega t dt, and whole integration we are going from 0 to t, that is for full cycle, plus v naught I naught upon 2 sine phi integral 0 to t sine 2 omega t dt. So in previous derivation we have already done that the integration of sine square omega t dt from 0 to t is t by 2, and the integration of sine 2 omega t from 0 to t is 0, because the integration of sine for full cycle or cos for full cycle is 0. So just we are going to write the values, that is this sine 2 omega t integrand becomes 0, so this whole term is 0, the second term of integration, and the integration of sine square omega t dt is 1 by 2. This we have done in the calculation of IRMS. This is t by 2, so this is 0, and this is v naught I naught cos phi into t by 2. So at last it becomes 1 upon t into v naught I naught cos phi into t by 2. So now what is the value of power? V naught I naught cos phi upon 2. So if we rearrange this 2 as root 2 into root 2, this equation becomes v naught upon root 2 into I naught upon root 2 cos phi. So v naught upon root 2 is Vrms, I naught upon root 2 is IRMS into cos phi. So average power is equal to apparent power into cos phi. So what is apparent power? The product of Vrms and IRMS is known as apparent power. The product of Vrms and IRMS is known as apparent power. Pause the screen and note down the derivation, and at last what we get, the result for the power delivered in AC circuit is average power is equal to Vrms IRMS cos phi, and Vrms into IRMS is known as apparent power. So here we come on a standard result that average power depends on cos phi, because Vrms and IRMS are constant values in AC circuit. It depends on the supply or input signal, but cos phi is variable because it depends on XL and XC. So in next lecture we are going to deal with power or cos phi. Thank you class.